All right, welcome. We are going to be looking at adding fractions. And in this little video, I'm just going to show you some very simple fractions and how to add them if you're dealing with fractions that don't have a common denominator. So there's several different ways that you can do this. And how you attack it is going to be different from perhaps how I attack it or how your friend may attack it. And so kind of bear with me. I may work different ways for each one of these. All right, so let's go ahead and take a look at the first one. One way to do it, and this always works, is to multiply the two denominators. If there's 3 or 4 fractions, multiply 3 or 4 denominators. Always works, never fails. Problem is, it might not be the best way because you might get just a monster fraction or a monster denominator when you're done. But in this case, it'll work. It'll be all right. The numbers are fairly small. So what we're going to do is we're going to multiply 2 and 3, and that's going to give us 6. 6 will be the common denominator. And so I'm just going to write that down initially. All right, now, to go back to it, I'm going to need to multiply not only the bottom but the top. See, if I just do it on one, I change the value of the fraction. But if I do it for both the bottom and the top, it's like multiplying by 1. So that way I don't change the value, but I do change the way it looks. So I ask myself, how did I get from 2 to 6 through multiplication? And it's 3. So I'm going to multiply the bottom by 3. I'm going to multiply the top by 3. It's 3 divided by 3, which is 1. And so you see that we're not changing the value. So we have 3/6. Over here on the 1/3, how did I get from 3 to 6 multiplying? I multiplied by 2. So I have to do that both top and bottom. It gives me a 2 here. Now that I have common denominators, the distributive property comes into play. If you're not aware of that, it basically says that if you have 3 numbers, we'll call them A and B and C, then you can, in either direction, distribute that out to AB plus AC. You take and you multiply across the addition. Now remember, subtraction and addition are essentially the same thing, at least as far as we're concerned. So in this case, then we can use the distributive property to come back from this instance and change it back into that. In our heads, the way we properly do it, now this might not be the way that you do it in real life, but this is the way it's properly done. It's 1/6 is the magical number that you're multiplying by, and then you add 3 and 2 in parentheses. That gives you 1/6 times 5, which is 5/6. The other way you can do it is, obviously, if you recognize that all I did was add the numerators, then you can just go ahead and add the numerators. That's it. That's all you have to do. All right, so now, maybe a slightly different way of doing it. So we'll work on this next one. What I can do is, I'm going to come over here and I'm going to say, all right, I'm going to split up 4 and 3. Oops, get rid of that. 4 and 3, and I'm going to turn these into their prime factorizations. Now, 3 is a prime number, so technically 1 is not a prime factorization. So 3 is just 3, the end. But 4 is 2 times 2. That means it's 2 squared, and we have a 3. So what I'm going to do now is I'm going to choose, from each prime factor, I'm going to choose the largest number of times it occurs. Meaning I'm going to choose for each set of 2's, I'm going to choose the largest exponent. In this case, we only have one set of 2's, it's 2 squared. And then I move on to the 3's, and we only have one set of 3's, it's 3. So what we're going to do then is we multiply all of these factors that we found, and we come up with 4 times 3, which is 12. So the common denominator is going to be 12. So when I do this now, I say, well, how did I go from 3 to 12? Well, you'll notice that 3 was missing this piece. That means that I take and I multiply it by 4, top and bottom. And then the 4 was missing this piece. And so I multiply 3 top and bottom. And I'm just doing this just the way I did before. 4 times 1 is 4. 3 times 1 is 3. If I add the two together, I get 7/12. Just remember, we just add across the top. That's the effect of the distributive property. All right, so we move on to 1/4 and 1/5. Same way. Again, because they share no common factors, all we have to do is essentially multiply the two together. I know that there are different techniques out there, so I'm going to show you one that I don't typically show my students, and the reason is because people tend to mess it up. The effect is there, but the reasoning behind it is the same as the two above. So here we go. 4 times 5 is 20. So my common denominator is 20. This is the part that you have to be very, very careful of. It doesn't work with 3 fractions very well. Some people have been taught that if you multiply across, that you can do the same thing. The short answer is yes, that works. The long answer is kinda. You have to be very, very careful with this. Mostly because the reason it works is you're assuming that you're multiplying the bottom by the same amount. If you change that amount, for instance, you bring this 4 up over here, but you only multiplied the bottom by 2, it's not going to work. In fact, it's going to throw it off. So you have to be very, very cautious that way. So we multiply, if you want to do it this way, we would bring 5 up and multiply it by 5. We bring 4 up and multiply it by 4. And that's where you get your 5 and your 4. And then when you combine these, that's where you get your 9/20ths. Okay, I don't really recommend it. But I know that there are people out there who just love doing it that way. And that's fine. It doesn't bother me. I just don't care to do it that way. So, on this last one, again, it's going to work just like the second one did. I'm going to multiply 5 and 6. Notice they share no common factors. This would change if they shared common factors. And how you do it in that case is, it depends on how much do you know about numbers, because numbers have a structure behind them. So 5 times 6 is 30. So I'm going to have a common denominator of 30 on each part. And then I'm going to come over here and I'm going to say, well, I multiplied 5 by 6, so I have to do that same thing to the top, so that when I divide them, I get 1. I have to multiply 6 by 5, so and the top also by 5. That way when I divide them, I get 1. That's going to give me 6 on top here, 5 on top here, and then when I add those, I get 11 over 30. Tell you what, let's do one more, but it's got some common factors involved. And I'll do it a couple of different ways. Yeah, let's do that one. So I've got 9 over 40 minus 1 over 30. Okay, so now they have a few factors in common. There's lots of different ways you can do this, and I actually used a way that I'm probably not even going to show. But one surefire way is to go ahead and multiply both of them. So 40 times 30 is really, to do it easily, is really 4 times 3, which is 12, and then 10 times 10, which is 100, so it's 1200. And so if I multiply by 40 times 30 over here, then I have to do that same thing to the top. Oop, I don't want to do it in yellow. I want to do it in purple. Multiply by 30 top and bottom. That way I only multiply by 1 in the end. On the second fraction, we'll multiply by 40 top and bottom. 9 times 3 is 27. Add the 0 on here for the times 10, so that'd be 270. And then I have 1 times 40 is 40. And then if I add those together, or I'm sorry, subtract them in this case, if I subtract those, I get 230 over 1200. If I recognize that when I reduce, I have factors of 10 in common, then I can go 10 divided by 10 is 1. They cancel. The effect when you're dealing with numbers in general, and these are real numbers, is that you just chop off zeros. That's the times 10. So we're left with 23, which is a prime number, over 120. Now 23 does not evenly divide 120. So we're done. And if you want a really quick way to check that, well, let's see. The numbers that make 0 when they multiply through are 5 and 10. Well, 5 times 23 is going to be odd, because 23 is odd, 5 is odd. And odd times an odd is an odd. In fact, it's 115. And then 10 times 230, or 23 is 230. You're already above it. So so there's really no reason to check anything else. Okay, so let's do this a little differently. You know, we had to reduce in the end. This other method will not preclude you from reducing, but it may make it a little easier. So we take our 9 over 40 minus our 1 over 30. We've already got an answer, so that's good. Over here, I'm going to take 40 and 30. I'm going to break them down into their prime factors. This is 4 times 10. 4 is 2 times 2. 10 is 2 times 5. 30 is 3 times 10. And then 2 times 5. That means that 40 is really 2 cubed times 5. 1, 2, 3 2s. Over here, it's 2 times 3 times 5. To find the least common denominator, or that least common multiple of the denominators, that magical number both are going to turn into, I look at the 2's, and I choose the larger between them. In that case, it's this 2 to the third. That covers the second 2. So there's 3 2's in the first number, 1 2 in the second number. The 3 and the 3 of that one cover the 1 in the other. You get like a deal. All right, and then we move on to 3's. Well, there's only this 3, so I choose it. And then I have a 5 and a 5. Okay, well, they're worth the same amount. Neither of them is larger than the other. So all I'm going to do is I'm going to choose one, and the other will go away because it's already covered. So as I'm looking at these numbers, all I have to do is multiply them back out. This is 2 times 2 times 2 times 3. Don't forget about the 3 over there. Times 5. All right, well, this is 3 times 5 is 15. Times 2 is 30. 2 times 2 is 4. 4 times 3 is 12. Add the 10, or multiply by the 10, and you get 120. Okay, so here's 12. Here's 10. 12 times 10 is 120. All right, so now that we have that, 120 is our common denominator. The other thing we can do is we can decide what's missing. Well, remember that the 40 had the 2 cubed and the 5. So 40 was this piece here. That means it's missing 3. So I'm going to multiply 40 by 3, top and bottom. Then, we'll choose blue here. Then I have the 30, which is a 2, a 3, and a 5. It's missing these two 2's. 2 times 2 is 4. So I'm going to multiply 30 by 4, top and bottom. When I do that, I get 27 in the first one, 4 in the second one, and if I combine those, I get 27 minus 4, which is 23 over 120. Several different ways to do fractions. You just got to pick one you like. And this isn't all of them. It's not comprehensive. So, anyway, take a look at it. If you want, go back, pause it. You can certainly go through it several times. It's the beauty of videos. So just go through, pick the one you like, just replay that one several times, and you'll have it. And pretty soon you'll be doing this like a champ. All right? Take care.